There is something so immense, so potentially world-shifting, that it will change the night sky forever. In the vastest reaches of the universe, stars are born, live, and die in astonishing ways. Among these celestial giants, one star in particular has recently captured not only the attention but also the concern of both astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out dramatically in the cosmic constellation of Orion. Betelgeuse is not just any star. It is large, colossally large, and very old. Its reddish color and the way its brightness changes have long fascinated humans peering up at the night sky. But in recent years, strange and unexpected events have made people even more interested in this cosmic giant. As we continue to learn more about Betelgeuse, it becomes clear we are standing on the edge of a major moment in its long history. What could these recent changes mean? Are we witnessing the beginning of a cosmic spectacle on an unimaginably vast scale? Betelgeuse is a stellar titan, 900 times larger than our own Sunday. That size is difficult for human minds to comprehend. Imagine, if you will, a star so massive that if it were to replace our Sun in the solar system, its outer surface would stretch far beyond the orbit of Mars. It would completely envelop Mercury, Venus, Earth, and even Mars. This staggering physical dimension does more than just showcase how impressive Betelgeuse is, it also gives us clues about where it currently lies in its life cycle. Right now, Betelgeuse is in the final stages of its life as a red supergiant. That means it has stopped converting hydrogen to helium in its core, a process that fueled it for millions of years. It is now expanding and cooling, marking a phase that precedes either collapse or explosive transformation. Scientists estimate that the star is between 8 and 8.5 million years old. That's relatively young for a star, but massive stars like Betelgeuse live fast and die young, evolving much more quickly than smaller stars like our Sun. Over those millions of years, Betelgeuse has changed dramatically to become the red giant we see today. Supergiant stars like it undergo immense transformations throughout their lives. These changes are the result of a constant and chaotic battle between the outward pressure caused by nuclear fusion and the inward pull of gravity. In Betelgeuse's case, what makes this late-life stage so unique and so visually distinct is its reddish color. That red hue is more than just beautiful, it is scientifically telling. It exists because the surface of Betelgeuse is significantly cooler than stars like our Sun. While the surface of the Sun is about 5,500 Kelvin, Betelgeuse's surface temperature is much lower, approximately 3,500 Kelvin. Because of this, it emits light at wavelengths that make it appear red to human observers. But the color is not just a visual phenomenon. It's a signal, a clue about the physical state of the star and the fusion processes unfolding within its massive, gaseous layers. The red color of Betelgeuse has not been constant over history. During the Roman and Chinese eras, historical texts suggest that the star was said to appear yellow. Around 2,000 years ago, it was described in ways that suggest a different coloration. In the 9th century, Arab astronomers were among the first to definitively claim it appeared red. This recorded shift in color throughout human history not only tells us how long we've been observing Betelgeuse, but also how the star itself has evolved over time. Another unique and compelling characteristic of Betelgeuse is its variability. Its brightness changes. Betelgeuse is a variable star, which means its luminosity rises and falls at regular intervals. This is not a new discovery. The variation in Betelgeuse's brightness has fascinated scientists and amateur skywatchers for centuries. The star follows a brightening cycle that lasts around 400 days, along with a longer cycle that spans approximately 5 years. As early as 1836, famed astronomer Sir John Herschel documented these changes in detail. Some Aboriginal stories may even reference Betelgeuse's fluctuations in brightness, suggesting oral histories that reach back even further. However, what truly makes Betelgeuse mysterious is not just that its brightness varies, but that it does so irregularly at times. Unlike other variable stars that dim and brighten with predictable consistency, Betelgeuse sometimes breaks its pattern. These deviations imply complex, less understood processes happening within or around the star's enormous structure. In late 2019, both astronomers and stargazers around the globe were shocked by what became known as the Great Dimming. Betelgeuse, one of the brightest stars in the night sky and a prominent feature of Orion, began to dim dramatically and inexplicably. The star's brightness dropped at a rate of about 0.01 magnitude per day on average. By February 2020, Betelgeuse had reached its faintest state in recorded memory. It had become so dim that even casual observers noticed. Normally visible to the naked eye even in cities riddled with light pollution, Betelgeuse now looked ghostly, its brightness reduced to a flicker. This unexpected dimming caused immediate speculation. Was it about to go supernova? Were we witnessing the precursor to one of the most violent and luminous events in the cosmos? Or was there a less explosive explanation? Adding complexity to the puzzle is the paradox of time. When we look at Betelgeuse, we are not seeing it as it is now, we are seeing it as it was about 654 years ago. That's because the star is approximately 654 light-years away from Earth, and its light takes that long to reach us. This time lag complicates efforts to monitor and understand rapid changes. By the time we observe a dramatic dimming, it may already be part of a long-past event in the star's timeline. The Great Dimming served as a stark reminder of how hard it is to observe the night sky in real time. It also revealed how little we truly understand about the unpredictable and violent behavior of massive stars nearing the ends of their lives. Andrea Dupree, deputy director of the Harvard-Smithsonian Center for Astrophysics, and her team launched an intensive 3-year study to monitor Betelgeuse's outer atmosphere and track any changes using the Hubble Space Telescope. These observations gave scientists new insight into the inner workings of variable stars like Betelgeuse. Variable stars frequently expand and contract, leading to changes in brightness. With Hubble's unique sensitivity to ultraviolet light, researchers were able to observe Betelgeuse's upper atmospheric layers, particularly regions heated by immense swirling convection cells. Thanks to these high-resolution observations, scientists determined that massive volumes of material were moving from Betelgeuse's surface into space at staggering speeds, up to 200,000 miles per hour. Eventually, this ejected material traveled millions of miles away from the star, where it cooled and condensed into a thick dust cloud. This dust cloud acted like a celestial curtain, partially blocking Betelgeuse's light and causing it to appear dimmer from Earth. This alone explained much of the Great Dimming. Dupree and her team concluded that this ejection came from Betelgeuse's southern hemisphere and involved nearly twice the normal amount of material released. The mass loss was extraordinary not only in size but also in speed, occurring far faster than anything previously recorded from the star. Naturally, this event raised one overwhelming question. Could this dramatic outburst be a prelude to a supernova explosion? The idea that Betelgeuse might go supernova in our lifetimes is both thrilling and terrifying. A supernova from a star so close, just 654 light-years away, would be visible even in daylight, possibly as bright as a full moon. It would be one of the most spectacular celestial events in human history. But would it be dangerous to Earth? Most scientists agree that Betelgeuse is far enough away that a supernova would not harm us, but it would radically transform our night sky for weeks, possibly months. Still, no one can say for certain if this is truly the end, or just another chapter in the long, complex life of this remarkable star. Betelgeuse's behavior remains an astronomical mystery. Is this dramatic dimming and mass ejection a final warning before collapse? Or is it simply a one-time anomaly in a star already known for its irregularities? Several theories now contend for dominance. One holds that this is just part of a highly active surface event, not indicative of imminent death. Another suggests that Betelgeuse might indeed explode within the next few decades or centuries, a blink of an eye in cosmic terms. Some even speculate that Betelgeuse has already gone supernova, and we are merely waiting for the light to arrive. Whatever the truth may be, Betelgeuse continues to fascinate and baffle, a giant ember in the winter sky whispering ancient stellar secrets from 654 years ago. One day, perhaps soon, we may witness its spectacular death, a moment that will forever reshape how we see the universe and our fragile place within it. Several teams of astronomers from different institutions began long-term observational campaigns, determined to monitor Betelgeuse every flicker and fluctuation. Using a combination of space-based telescopes like Hubble and ground-based observatories such as ALMA and the Very Large Telescope, scientists gathered a flood of data. They studied the star's light curves, spectroscopic signatures, surface dynamics, and surrounding environment. One major finding during these efforts was that Betelgeuse's sudden dimming in 2019 to 2020 wasn't the result of the star itself shrinking or cooling dramatically, as initially feared. Instead, the dimming was primarily caused by a dense dust cloud formed from material ejected during a powerful surface eruption. This cloud temporarily obscured our view, especially from Earth's vantage point, making the star appear much fainter. The confirmation of this helped calm widespread speculation that the star was about to go supernova imminently. However, it also opened up new questions about the nature of such ejections and how frequently they might occur during the late stages of a red supergiant's life. Some scientists proposed that the Great Dimming was an example of a phenomenon called a surface mass ejection or SME, an event similar in some ways to solar flares and coronal mass ejections on our own